Welcome to all our attendees. I'm Varun, an industry principal at TechVision business unit of Frost Sullivan. I lead our work in sensors, microelectronics, and advanced manufacturing and automation sectors, focusing on providing intelligence, strategic insights, and in-depth technology research. So I'm delighted to be sharing my perspective today on the topic growth opportunities in smart and sustainable manufacturing, which is driving scalable transformation with the three elements, that is data, ecotech, and circular principles. So for session today, we have a comprehensive agenda. The first one is the introduction part. Why smart and sustainable manufacturing now? Strategic imperatives shaping the landscape, technology as a growth analyst catalyst, sustainable manufacturing in action, and transformational pathways for manufacturers. So here, to kick things off, I would like to introduce my other two colleagues and expert speakers, each with significant experience in smart manufacturing and sustainability. Over to you, Jacinth and Sujita.
Thank you, Varun. Hi, everyone. I'm Jacinth Matthew, and I'm a senior research analyst with the TechVision division of Frost & Sullivan. I'm basically focused on sensors, microelectronics, and a little bit of ICT, and also advanced manufacturing technologies. So my experience with Frost & Sullivan is almost for 2 years now, and I'm excited to join this discussion. Over to you, Sujita.
Thank you, Jacinth. Hi, everyone. My name is Sujita Tripathi, and I am an associate in TechVision team. And I basically work for mobility, semiconductors, microelectronics, and sensors group, and as well as manufacturing industry sectors. Thank you so much.
Yeah, thank you, Jacinth and Sujita, for the excellent introduction. So moving on to the next slide. So today, if you see the manufacturing landscape is at a pivotal turning point. So you can see a convergence of global disruption from geopolitical instability and supply chain weaknesses to climate risk and tightening regulations, which is fundamentally changing how we design, operate, and scale productions. In this new reality, manufacturing must simultaneously and strategically achieve the efficiency, resilience, and sustainability. So, therefore, the luxury of choosing one is gone. Looking at the transformational trends, what we are seeing is the fundamental shift where the manufacturing is moving away from a resource heavy, linear models towards data centric, circular, and adaptive value networks. The reason being, like, it can be the rise of the Industry 4.0 technologies like AI, digital twins, and advanced analytics is not just about the automation part, and it's about augmenting the human decision, creating an agile operation, and also reducing the environmental impact. So here, let's consider the real-world example where Ferrari Maranello e-building, where luxury meets the sustainability factor. So back in September 2024, the Ferrari company unveiled their impressive more than $225 million e-building in Italy, which envisioned as their most efficient and sustainable production site. So it boasts around like 3,000 solar panels and rainwater harvesting to shrink their carbon footprint. Plus, they have also integrated AI and autonomous trolleys to boost their efficiency and flexibility, which are part of Ferrari's commitment to carbon neutrality by 2030. So this impressive example from Ferraris demonstrate that how even traditionally high performance industries are embracing sustainability at their core engineering factors. So now let's zoom out and understand the broader forces which is driving this urgency. So the why factor now, like the pressing drivers for the sustainable manufacturing, like there are around four factors which is driving the sustainable manufacturing. The first one can be the increasing regulatory pressures like the scope 3 emissions, which tracks and extended the producer's responsibility. And the next factor is the growing investor expectation around ESG, transparency, and reporting. And the third one is the stronger customer demand for ethically sourced, traceable, and environmental friendly products. And the last one is the crucial factor, which is the talent by the next generation engineers or manufacturers wants to contribute to be purposeful and tech forward companies. So on the next slide, we would like to hear from the audience, like our first poll question. So what is the biggest driver pushing your organization towards the smart and sustainable manufacturing? So whether it is regulatory and compliance measures or cost saving and operational efficiency, or it can be customer and market expectations, and it can be also long-term resilience and risk mitigation. So please do respond to this poll question, and let's wait a minute for your response on that. So interesting results. We are seeing some strong responses in all key areas like cost savings and customer expectations, and also the long-term resilience. So this confirms that the complexity and importance of this shift. And as we can see, with so many compelling reasons to adopt these practices, it naturally leads us to the next point, like how sustainability is no longer just a compliance issue, but a significant strategic lever for the competitive advantage. So the why factor is becoming increasingly clear now. So now let's examine how leading companies are leveraging sustainability, not just as a necessity, but as a strategic strength. So, as a sustainability which has evolved beyond a mere compliance exercise, it is now a powerful driver for operational efficiency and cost reduction, as well as the innovation and enhanced brand reputation of the companies. So, the companies actively integrating circularity, zero waste principles, and carbon aware production, which are not just minimizing the risk, but they are forging the significant competitive advantage. So, if sustainability is a strategic lever, what does a truly future-proof manufacturing operation looks like? So, let's outline the key characteristics of the sustainability factors. So, what defines the future-proof manufacturing? So, these are like manufacturing systems built with the future are fully digitally connected, and also they are intrinsically designed for circularity, and also they are completely transparent and traceable throughout the supply chain, and they are highly resilient to both market fluctuations and as well as for environmental crisis. So the real question is not if how the why the smart and sustainable manufacturing is necessary, but it is how rapidly and how holistically we can achieve this transition. And in our next segmentation, like we'll deep dive into what exactly and how leading organizations are deploying scalable real world solutions to make this transformation a reality. On the next slide, so now I'd like to hand over to Jacinth, who will start us off with his perspective on what are the strategic imperative that is shaping the landscape. Over to you, Jacinth.
Thank you, Varun, for the comprehensive overview of smart and sustainable manufacturing. As Varun elaborately explained about the key drivers of what is basically pushing companies towards smart and sustainable manufacturing, I would like to touch upon some of the other strategic imperatives or key factors that basically are impacting companies towards their transformation towards smart and sustainable manufacturing. Out of those, I think we can have around 6 points in this slide shown. And out of those, I would like to highlight few important. And the first one among those is the geopolitical chaos or geopolitical conflicts. We can see that the tariff volatility and recent trade block shifts around the world, for example, the recent tariffs by United States on Europe and India and China and major other economies, we could see that such kind of imports are disproportionately impacting some kind of sectors, for example, automotive and the steel and semiconductor sectors. And these kind of geopolitical chaos has basically forced the companies to move towards deglobalization, and their trend is towards supply chain fragmentation. So companies basically what they do is they want to secure and their own resources and focus only on their localized economies. And such trends also focus on nearshoring or reshoring or tech shoring, we can call it. But what's finally happening is that companies and countries are basically focusing towards growing their own economies, growing their own localities, rather than going for at the global level. So this kind of a trend is basically shaping companies towards sustainable and smart manufacturing policies. And the second one I'd like to highlight is the compression of value chain. If you see, like in the past, the value that time to market of a product from the initial conception of the idea to the final product would be a long and tedious process. But right now we could see that due to AI and other advanced software and technologies, we could see that the value chain has basically been reduced to a mere few steps. Including, for example, spatial computing and digital twins are being used to merge multi-pronged data, including sensor data or statistical data or people data, and it's combined into a unified model where companies can collapse their design to delivery systems or cycles into a very short time frame. So we could also see that virtual product development is going on. VPD, they basically slash the physical prototyping and use simulation, and computer aided designing has been there for a long time. And the such kind of trends are definitely impacting, and also there is growth in direct to consumer and digital consumer experiences. So this kind of compression of value chain are impacting the companies. And the third one I'd like to touch upon is supply chain resiliency and transparency. As Varun talked about transparency, we could see that every step of the product development, or up to the last or end user, we could see that it is being visible, and can be achieved even using emerging technologies such as blockchain or even IoT based tracking. So there such kind of transparency, what happens is companies need to go the smart way. They cannot go the legacy way or in the older or dated systems. And the next one is regulatory compliance, which is taking place, which is again, as Varun has covered, which is kind of linked to the geopolitical chaos and how these are important. And the last one is about new business models and strategic partnerships, and how companies are collaborating, and they are joining to form new business ideas and getting new models to gain revenues. So I think these are some of the basic strategic imperatives which are impacting companies. And I'd like to hand over to Sujita to touch further upon the technological aspect of this.
Yeah, thank you so much, Jason. So further, we will move on to the technologies which are working as growth catalysts for a sustainable future. So technologies actually play a pivotal role in accelerating the shift towards the smart and sustainable manufacturing. And here we will be discussing about six major technologies which are working as growth catalysts for sustainable manufacturing processes. So first one, which we will touch is Industrial Internet of Things (IIoT). So IIoT technology is helping the manufacturing sector by connecting machines, devices, sensors, and systems through the internet to collect and exchange the data. This integration actually enhances the operational efficiency and improves the decision making and drives the sustainable practices. It enables real time data monitoring, predictive maintenance, process optimization, and energy management. Manufacturers that actually integrate IIoT in their manufacturing processes, manufacturing value chain, they can achieve higher productivity, reduce the wastage, optimize energy consumption, and create eco-friendly products. Ultimately, they can align their operations with global sustainability goals. So, for example, we have example of Siemens. Siemens has a platform called MindSphere. MindSphere platform actually connects companies' industrial assets to the cloud, and it enables manufacturers to analyze their performance data. Meanwhile, it identifies the inefficiencies in the manufacturing processes and optimizes the production processes also, and resulting in reducing downtime, reduced downtime lowers the cost, and it drives sustainable growth. Next technology, which is here to be discussed, is predictive analytics. Predictive analytics actually leverages AI, machine learning, and IIoT data to anticipate the disruptions in manufacturing, equipment failures, shifting market conditions before they impact the production. By analyzing data from sensors and historic trends and the SCADA, which is supervisory control and data acquisition systems. So by analyzing these data and trends, predictive analytics actually enables manufacturers to make proactive decisions and streamline the operations. The key benefits of using predictive analytics in manufacturing value chain is manufacturers can obtain increased operational efficiency. It helps in reducing the wastage and scrap by detecting the uh, defects in the early stage, and it helps in enhancing the resource utilization also. And meanwhile, it also helps in lowering the carbon footprint. For predictive analytics, we have an example of General Electric. General Electric has a platform known as Predix. So Predix actually uses AI to predict the equipment failures in sectors like aviation manufacturing, and it helps company to reduce unplanned downtime up to by 40%, and it helps in cutting the cost and boosts the uptime. Next technology, which we are moving on to, is energy efficient systems. Energy efficiency, as we know, in manufacturing, actually involves optimizing the energy usage to maintain the performance while reducing consumption and emissions. This is achieved through sustainable practices, advanced management models, and investment in innovative technologies. So key benefits which companies can obtain by implementing energy efficient systems in their manufacturing value chain are, first of all, is it is cost reduction. By lowering the energy consumption, it can lead to decreased operational expenses. Then lowers the environmental impact by minimizing the energy wastage, and it also reduces greenhouse gas emissions. Then operational efficiency can be improved by enhancing the energy management, and by improving the overall production process. For example, we have Schneider Electric and Bosch. Schneider Electric has a eco-structure platform which enables comprehensive energy monitoring and automation. And Bosch has a smart factory. Bosch has implemented smart grid solutions that adjust energy consumption dynamically based on their production needs. So these are the examples we have for energy efficient systems. Then the next technology which we are moving on to is smart automation. Smart automation leverages robotics, AI, and real-time analytics to create intelligent, adaptive manufacturing systems. It replaces the repetitive tasks with autonomous processes, and it enhances the flexibility and reduces the human error. It also reduces the energy wastage and downtime. Technologies like IoT, digital twins, and machine learning, they drive optimization across the production line in smart automation. So the key benefits manufacturers can obtain by implementing by using smart automation in their manufacturing value chain is, first of all, is enhanced operational efficiency. Smart automation actually streamlines the production by reducing the manual interventions and leading to faster cycle times. Then improve product quality because automation ensures consistent production quality by minimizing the human intervention and human errors. So it improves the product quality. Energy and resource optimization can be improved by utilizing smart automation, because smart systems monitor and manage energy consumption and lead to significant energy savings, and yeah, obviously cost reduction. And then the sustainability and environmental impacts are also improved by smart automation, because they contribute to sustainability by optimizing the resource usage and reducing the waste. So, for example, we have Ford, Tesla, and Mitsubishi Electric. Like Ford's transmission plant in Michigan, it incorporates AI technology from Symbio Robotics, and it results in a 15% increase in assembly speed for torque converters for Ford. And for Mitsubishi Electric, smart manufacturing, it's the company's smart manufacturing approach connects every stage of their production process, like from engineering to the shop floor, using advanced automation technologies. This integration actually enables real time data collection and analysis for them, which facilitates informed decision making and process optimization. Then the next technology we are discussing is digital thread technology. Digital thread is a data driven communication framework that connects traditional elements in manufacturing processes and provides an integrated view of an asset throughout its life cycle. It actually enables seamless data flow across various stages, from design and production to maintenance and end of life, and facilitates the real time decision making and enhances the efficiency. Its major applications in manufacturing can be like product life cycle management, uh, by providing a comprehensive view of a product's life cycle. It enables better design and development and maintenance decisions. Then it helps in quality assurance by enabling real-time tracking and monitoring of materials and components. And then it helps in supply chain optimization by enhancing the traceability and streamlining the formulation management. It ensures compliance across key areas such as quality, safety, sustainability, etc. And then of course it helps in smart manufacturing by facilitating the integration of technologies like IoT and digital twins and etc. For example, of digital thread technology, we have Vistas, which was recognized as the world's most sustainable energy company in 2022. uh, the company is targeting the production of zero waste wind turbines by 2040, while addressing current customer demands, including increased transparency and about their product carbon footprints. So, to support this vision, Vistas collaborated with PTC to establish a model-based digital thread built on a robust product lifecycle management system for enterprise level traceability and control. Uh, so the digital thread enables a continuous closed loop flow of data throughout the product life cycle, giving Vistas access to valuable insights for smarter decision making. That's how Vistas have implemented digital thread technology. The next technology we have is additive manufacturing. Additive manufacturing is a very well-known technology, commonly known as 3D printing, and it is a manufacturing process that creates objects layer by layer from a digital 3D model. So, unlike traditional subtractive manufacturing like cutting, machining, drilling, these processes which remove material from a solid block, additive manufacturing actually builds up parts only where needed. So, it reduces the wastage and enables complex designs that are often next to impossible with traditional methods. So, there are also advanced forms of additive manufacturing like 4D printing and 5D printing. So the major benefits which manufacturers generally obtain by applying additive manufacturing in their manufacturing processes is material efficiency by reducing the material wastage by depositing material precisely where needed. Then energy conservation by producing lighter components and reducing the need for extensive machining. Design flexibility, because additive manufacturing allows for the production of complex geometries which are almost impossible with other machining processes. And then it supports localized manufacturing, allowing for manufacturing closer to the point of use. So that's how additive manufacturing helps manufacturers. And for example, we have BMW Group. BMW Group has been using 3D printing for over 30 years. And now it is also applying 3D printing for producing tools and robotic aids across production. So, as technology propels our industries forward, it sets the stage for more than just growth. So, it enables responsibility also. So, now Varun will let us know how innovation drives real world impact through sustainable manufacturing in action. Over to you,
Yeah.
Varun.
Yeah, thanks, Sujita. So absolutely, as you said, like technology is indeed the core engine driving this sustainable transformation. From the data-rich insights provided by the industrial IoT and the optimization power of predictive analytics, and to the resource efficiency of smart automation and energy efficient systems, and crucially the digital twin encompassing the new concept that is digital thread of a product life cycle along with other innovations like additive manufacturing technologies. So they act as a crucial catalyst for the growth in the industrial sector. So it also enables us to achieve greater efficiency, reduce cost, as well as embrace sustainability and build true agility over the manufacturing sectors. So coming to the next slide, so now let's bring the theory into action by looking at how circular design principles are being implemented in sustainable manufacturing. Globally, we generate an astounding amount of waste each year, making the shift to a circular model not just beneficial but essential. So, as a definition at its core, circular design is about designing products and systems that eliminate the waste and keep the materials in use for as long as possible. So, this is a fundamental shift away from the traditional linear take, make, and dispose approach. And this circular design really focuses on three key areas. The first one being the design for durability and reuse, and the second being the prioritizing the recyclability and the modularity, thereby creating products that can be easily taken apart and their materials recovered or individual components upgraded. And the third, by using a sustainable, non-toxic and regenerative materials, opting for things like bio-based plastics or recycled content. So we are already seeing several manufacturers successfully applying these circular design principles. For example, in electronic sector, companies like Fairphone are building modular smartphones designed for easy disassembly and upgrades, extending their lifespan. Also, in the case of automotive sector, major OEMs are increasingly remanufacturing their components, which not only saves the cost but also significantly reduces the need for the new raw materials. And also in textile sector, a crucial area where we are seeing a closed loop fiber recycling being integrated into the product design right from the start, meaning the materials are intended to be recycled back into the new clothing. So this shift requires design and engineering teams to collaborate closely with supply chain, and designers now need to consider what happens to a product at the end of its life just as much they focus on the aesthetics or how will it functions initially. So, as Sujita mentioned on the technologies like digital twins, virtual copies of products and processes and life cycle analysis tools are becoming very essential here. Like it helps teams to simulate and optimize product circularity even before the production begins, which allows them to identify the potential issues and make better design choices early on. Of course, like adopting these principles is not without any challenges or hurdles. So, cost can be a factor, and also sourcing sustainable materials can also be complex, and also setting up reverse logistics for product take back and recycling requires a new infrastructure. So, however, like we are seeing many leading companies are actively addressing these challenges through innovation hubs or forming strong partnership with their suppliers, and also working aligned with the evolving environmental policies. So to further solidify our understanding, so let's now examine some specific examples of how companies are putting circular design principle into practice. So our next slide shows, like, let's uh, showcase some of the insightful case studies. Like, you can uh, take a major player in the technologies, which is Dell, and their advancements in sustainable technologies through circular design. So they, in 2024, they have significantly intensified its commitment to sustainability by incorporating a substantial amount, over 95 million pounds, of recycled or renewable materials directly into their products. So they have gone beyond just these materials, and they have redesigned their hardware from the ground up to make up their device more repairable and long lasting. So when you look closer at their materials usage itself, they have included low emission aluminum material, which reduces the energy needed for production, and also they have integrated bio based plastics, which lessening our reliance on fossil fuels. So, and also they have utilized recycled cobalt material, and even reclaimed copper and steel. So the Dell company has made an incredible strides in eco-friendly packaging as well, with over 96% of their packaging materials being reused or renewable and recycled. So this emphasis on modular design, which is a key, making it easier to take the products apart from repairing or individual components, and ultimately recycle materials at the end of the life. So it's a strategic shift for Dell company, moving away from the traditional linear take, make, and dispose model towards a truly circular approach focused on long-term sustainability and efficient resource use. So importantly, like, Dell's efforts directly align with the broader global environmental objectives, showing a real leadership in reducing the reliance on virgin materials and championing circular economy. So all this, like, firmly positions Dell as a leader in uh, sustainable technology practices, clearly demonstrating the vital role on the circular design in the tech industries. The other example which we are seeing is this Philips, which is another prime significant global leader, truly embedding circular manufacturing innovation in their operations. So this multinational technology firm has clearly demonstrated its commitment to circularity through several key initiatives. Most notable, like, they have implemented a program called the Green Products Ecosystem Program, so which is built on the core principles of refurbishing products, rigorously recycling materials, and strategically reusing the components. So the result of it has got an extended lifespan of their products and significantly reducing the waste. And like, in 2020, the Philips had already achieved the circular performance in products of around 15%, and they have set an ambitious target to reach 25% by this year end. So this commitment also highlights that circularity permeates their various business units. Like, for instance, we can take the Philips lighting, for example. So they have adopted an interesting product as a service model for their lighting solutions. So this means that they work in close collaboration with their customers to offer a tailored lighting, ensuring that optimal performance and taking responsibility for ongoing maintenance, which is naturally extends the product's lifespan. So this is a departure from simply selling a product and leaving the end of life management to the customer. And similarly, in Philips healthcare division, so their healthcare division has a strong focus on the refurbishment and remanufacturing of medical equipments. So this approach is not only about financially prudent, but also it certainly cuts the medical equipment cost, like, for the healthcare providers, and also makes a significant contribution to the considerable, like, environment impacts associated with the manufacturing brand new complex medical devices. So ultimately, if you see, like, implementing this circular design is not just about reducing our environmental footprint, but it's about building a truly resilient, future-ready manufacturing system that are inherently more adaptable to changing demands and evolving regulations. So I would like to ask Sujita, like building on this idea of sustainability input, what are your thoughts on integrating the green materials into the sustainability factor? So could you please elaborate on that stuff?
Sure, Varun. Thank you so much.
Yeah.
So, integrating green materials refers to the adoption of environment friendly, renewable, biodegradable, recyclable, and low carbon input materials in the manufacturing processes. So, these materials are basically designed to minimize the environmental impact throughout a product's life cycle, from sourcing and production to their usage and disposal. Major green materials that can be used in manufacturing processes are biodegradable materials, recycled materials, and bio-based materials, and low carbon alternatives like green steel or carbon negative cement. So, integrating these green materials have some major impacts on manufacturing processes, and for manufacturers, like they lower the environmental impact by actually green materials have often have lower embodied energy and greenhouse gas emissions, resulting in lower carbon footprint compared to conventional materials. So they basically minimize the chemical waste and hazardous byproducts during manufacturing. So, and next is they improve the eco-friendliness through the use of recyclable and biodegradable components that minimize long-term waste. Then next is advancement of circular economy. Green materials are basically designed for end of life recovery, supporting closed loop systems. They enable manufacturers to reduce landfill contributions by creating biodegradable or upcyclable products. Next is economic advantages. So integrating green materials actually helps in cost savings. So through those sometimes higher up they have higher upfront, but green materials can reduce life cycle costs through energy efficiency and lower disposal fees. And then they contribute in innovation and product performance by encouraging research and development. Adoption of green materials pushes manufacturers and companies to innovate in product design, processing, and packaging. So, many green materials offer enhanced properties like biodegradability and lower weight and better durability. For example, we have Patagonia and IKEA. So, Patagonia actually Patagonia has been a pioneer in sustainable apparel by replacing conventional materials with environment friendly alternatives. They utilize recycled polyester derived from plastic bottles, and they utilize organic cotton. So, as of 2023, as the company claims, over 90% of Patagonia's products incorporated preferred materials, including recycled polyester and organic cotton. And the transition to recycled polyester has prevented approximately 153 million pounds of CO2 emissions since 2019, as the company claims. So they have developed systems to trace materials back to their origins, and they ensure ethical sourcing and environmental responsibility. The next example we have of IKEA. IKEA has committed to using only renewable and recycled materials in all their furnitures and all their products by 2030, aiming to become a fully circular and climate positive company. So their key initiatives are like first one is mushroom based packaging. So IKEA has initiated replacing their traditional polystyrene packaging with biodegradable mycelium based alternatives, which was developed by Ecovative Design. So this mushroom packaging decomposes naturally within weeks and reduces landfill waste. Next initiative they have taken is recycled furniture lines. So IKEA has introduced furniture lines made from recycled materials like for their kitchen fronts, which utilizes recycled plastic bottles and reclaimed wood. So, as we embrace green materials to build a more circular and responsible future, the next step is to power this transformation with innovation. So, I think Jason will take us for there. Over to you,
Yes,
Jason.
thank you. Thank you, Sujita. I think in addition to what Varun and Sujita has covered, I'd like to talk about the ecotech innovations that are actually impacting sustainable and smart manufacturing. Out of these, I think the digital transformation is there: carbon capture, renewable energy, bio-based material, and optimizing logistics. I think in the previous slide, Sujita covered about bio-based materials. We could see that algae-based or even advanced polymers such as plastics and any other even advancements in plastics. I mean, like biocompatible plastics or any other innovation in that area. We could see that those are being used in sustainable manufacturing, and also in terms of carbon capture. We could see that there is carbon capture is basically not a core manufacturing technology as it is, but it can be considered as an outside source which contributes to sustainable manufacturing. Within carbon capture, there has been like a lot of technologies. We could see that there's post-combustion carbon capture, which removes CO2 from the exhaust gases in industrial process like power plants and for example, in the energy sector. And there is oxy-fuel combustion, and in this method includes burning fuel in an oxygen-rich environment, which produces a steam which consumes the CO2. So this kind of carbon capture technology, there is also cryogenic or chemical looping, or even membrane separation technologies, which are coming under carbon capture technologies. Then we have renewable energy and generation and storage. Renewable energy, the one name that we come across is solar technology, which is widespread available, and even that has a lot of innovation going on. And we could also see that in going to digitization, we could see that renewable energy comes in various factors. For example, there is RF energy harvesting technologies, there is light energy harvesting, thermal energy harvesting technologies coming up. For example, if IoT is being applied in a large scale in manufacturing, it needs to be supplied with proper power. So energy harvesting at the smallest unit level, at the sensor level, is going to take place, which can definitely contribute to lowering the overall power consumption of the factory. And then we have energy storage, for example, advancements in lithium-ion batteries, or even in newer batteries technology. We could see that such kind of innovations are contributing to smart and sustainable manufacturing. Then to touch upon optimizing logistics and transportation. This again, just like carbon capture, is not a core manufacturing technology. It comes under, I mean, a supportive technology. It operates basically outside of the factory, but still contributes to smart and sustainable manufacturing. Even we could consider electric vehicles as a part of sustainable manufacturing, because at the logistic end or at the transportation end, they could contribute to lowering emissions, carbon emissions. And then we have optimizing logistics. For example, AI models could be leveraged to optimize delivery and logistics so that the minimal resources are being consumed. So out of all these five, the most important out of these is digital transformation. And we all know why we covered so much on that in the previous slides, because the advancements of AI in the last 10 years or last 15 years has been so impactful that every other emerging technology, including IoT or including sensors, including edge computing, including robotics, such kind of technologies are equally developing at the same time. And we could see that live. We could see that all these technologies are collaborating at the same time to have that actual sustainable and smart manufacturing take place in real life. So if you can go to the next slide, I'll just touch upon a few case studies out of these. Yes, I actually brought about two case studies which are basically similar in as it appears, but the key difference is both are basically a kind of a digital twin or a machine vision system. On the left side, we could see that there's Ford Motor Company. What have they have done is they've implemented an AI-powered machine vision system, employing multiple cameras, including lidars and smaller sensors. But what they've done is they've used advanced AI models and deep learning models to detect surface faults or any misalignments or paint inconsistencies in their products. And what they've done this over a 18-month period actually, and they've realized that it could reduce the defect rates by up to 90% and also lower their maintenance costs. And at the same time, it could increase the inspection speed by 30%. So we could see that Ford is basically a very established and with a long history. So how can a company which has been existing for such a long time implement a new or emerging technology in their infrastructure? We could see that this is the success that they have achieved, and they have the key word we are looking for is interoperability. So they have successfully established a machine vision system in their existing infrastructure to achieve this kind of benefits. And the next one is Siemens AG, the German-based company. And what they've done is they've implemented a digital twin in the plant in Hamburg, which is based out of Hamburg. And what is unique about this is their scalability. Basically, what they've done is they've implemented the digital twin throughout their large-scale factory, and they're able to monitor even the smallest changes or smallest faults in their in the factory or in the infrastructure, even up to a bolt or even up to a small inconsistency. So this has basically reduced their scrap consumption by 30%, which has optimized their material consumption. And we could see that the digital twin has reduced their energy consumption also by 20%. So this has also led to greater downtime-free production. So these two examples, I think, are pretty much very important, and how smaller companies or even medium companies could learn from bigger players how interoperability and scalability are the most important factors in applying emerging technologies. So that is basically from my end on ecotech innovations.
Yeah. Thanks, Jacinth. Definitely the manufacturing sectors is shifting towards a circular design, use and reuse model driven by product lifecycle thinking and accelerating the adoption by major companies. So this transition is powered by the green materials as well as the eco tech solution, requiring a strong value chain collaboration and ultimately building a greater resilience against the environmental and economic pressures. So moving on to the next slide. So now as we look ahead to our final segmentation. So Sujita, what are your thoughts on perspectives on the efficient transformation pathways for manufacturers to achieve this smart and sustainable manufacture for the future?
Yes, Varun. We have a few strategic alignment, strategic initiatives which we believe manufacturers should take for their sustainability goals. First one is, I believe, embracing circular economy principles by prioritizing the design for recyclability and reuse by focusing on reducing the wastage and reusing the materials. The next one is, I believe, manufacturers should prioritize adopting energy efficient technologies, which we know that most of the big manufacturers are already implementing by investing in energy efficient machinery, renewable energy sources like solar and wind power, and energy recovery systems. Next one is integrating digital manufacturing tools like IoT, AI, digital twins. By implementing IoT sensors for real-time monitoring, AI for process optimization, and digital twins to simulate and optimize manufacturing processes. Next one is optimization of supply chain sustainability. Manufacturers can initiate to choose suppliers with which follow sustainable practices like and which who promote ethical sourcing and use a digital thread for transparency across the supply chain. So sustainable sourcing reduces environmental impact and aligns operations with global sustainability expectations. And then next one we have enhancing the waste reduction and recycling initiatives. Manufacturers can implement waste reduction processes, prioritize material recycling, and aim for zero waste production. Reducing waste not only benefits the environment but also reduces the disposal cost and can lead to new revenue streams through recycling, helping the manufacturers. Then fostering collaboration across industries, engaging with partners, governments, and sustainable organizations to share best practices, policies, and technologies can help manufacturers for their sustainability goals. So, and the last one we have is policy and regulatory initiatives to advance smart and sustainable manufacturing. Governments and stakeholders must collaborate to create policies, provide incentives, and establish frameworks that promote innovation and environmental responsibility. A recent example of such an initiative is Australia's Future Made in Australia policy, which was launched in April 2024. So, as companies align their strategies with global sustainability goals, the next crucial step is turning intent into impact. So, now I think Jason will explain how data driven and resilient ecosystems can impact the transformational pathways for manufacturers. Over to you, Jason.
Yes. Actually, in my point of view, I think the three most important actionable items that companies need to take are: first one is modular by design, and the second one is hybridized adoption, and the third one is integrating core technologies and processes. Modular by design, as we've covered throughout this section, modularity is one of the most important aspects that manufacturers need to look into, because as we all know, recycling used to be something like didn't have a good name maybe for 10 to 15 years back. But right now, recycling is being increasingly put into manufacturing, and remanufacturing or recycling is again being highlighted in every aspect due to growing resource constraints. So we could see that modular design is primarily the most important aspect, so that companies could definitely disassemble and reuse their products and keep the product be used for a very long time. And uh, and the second one, I think, is integrating core technologies and processes. Integrating core technologies not only includes like the technologies that we talk about, for example, digital twins or AI or even robotics. We could also include optimizing processes, which are very much important. So, I'm trying to say is that only a particular technology or one particular technology like AI or one particular technology like robotics is not going to benefit manufacturers in the long term. So they need to be able to integrate external technologies, optimized processes, even eco-tech technologies, or even bio-based materials, and they need to be advanced in every aspect so that they could stay relevant in these continuously changing times. And the last one about I need to touch upon is hybridized adoption. Hybridized adoption is again very paramount for companies right now. For example, if you look at additive manufacturing as a technology, it's a very highly looked upon technology. But then again, we can't incorporate it completely in for a manufacturing facility. The companies need to adopt a combination of additive manufacturing and CNC machining. So this kind of the balance between emerging and existing technologies needs to be considered and needs to be implemented. For example, there is growth in edge computing. For example, NVIDIA's advanced GPUs and even Google's tensor processing units are promising technologies that enable companies to think about edge computing. But then again, even cloud has advancement. So companies can again be a form of hybridized format like edge and cloud computing. And similarly, there are other hybridized format. For example, recently I heard about news from China that the companies are adopting a complete dark factories. For example, they've automated everything from end to end and replaced the entire human workforce in those companies. And I think these are basically like phone manufacturing companies, and some are like automotive companies. So we could see that this kind of process is actually possible, in my opinion, only in few areas. For example, in an economy like China, which is a manufacturing hub, we could see that such kind of factories are feasible. But then again, what I would suggest to companies is go for a hybridized version, balance between your manual workforce and your robotics or automation, so that it will be a balance of both economically advanced, at the same time very smart and sustainable. So I think these are some of the most important things to add on to vouch for modular and to recycling initiatives. Actually, with the rest of the panelists, we worked on a recent consult project in material and metal manufacturing actually. And we found that recycling metals actually had the same properties or same attributes or strength to weight ratio, or even the characteristics of the newly mined metals. So we could see that even in other technological areas or even in other sectors, recycling products basically yields the same result or same capabilities as a newly manufactured product. So I think these are the most important aspects of building circular, data-driven, and resilient ecosystems. If you could move to the next slide, I'll touch upon a few use cases. And so this is one particular use case which I wanted to highlight. Out of the 3 points that I mentioned, optimizing the processes is this particular use case actually highlights that. This company actually is a very famous automotive company, Yamaha Motors, and what they've done is they've not used actually major technologies, but they've used a optimizing process known as theoretical value energy. So what they've used it to achieve their carbon neutrality in their factories, and we could see that they've basically classified their energy consumption into value, semi-value, and no value, and they aim to reduce their consumption in semi-value and no-value operations, and they designed this for minimization and clean energy consumption. The company also, what they've done is they've integrated AI and automation to enhance their production in this and to achieve their goal of carbon neutrality. So this example I found interesting because they're using a process what they've invented on their own, based on their own factories, based on their own infrastructure. They developed this process which optimizes their operations to reduce their power consumption to reach a sustainable manufacturing goal. So this particular example, I found it interesting. I'll hand over to Varun to further give his opinions on this.
Yeah. So yeah, thanks, Jason and Sajita. So to summarize, as Jason and Sujita mentioned, the transition to smart and sustainable manufacturing requires a holistic system level vision that balances economic growth with environmental responsibility. While technology is very crucial and embedding the sustainability in companies' culture, leadership, and workforce is essential for lasting change. So this shift is not just ethical, but it provides a significant strategic advantages and fostering agility and competitiveness across the manufacturing sector. So I would suggest the time is to act is now, as early adopter will shape the future of the industry economy. So I see that we have come to the end of the final section. So I would like to highlight some of the uh, key points where the manufacturers can take a strategic step in achieving the sustainable manufacturing concept. So firstly, like start with the strategy. Like take a critical look at your organization's alignment with sustainability goals. So also do a feasibility check on your product development and supply chain management and innovation strategies, that is truly future ready or not. And secondly, invest strategically in circularity and data concept, where prioritizing and allocating resource to implement the circular design principle, which establishes an efficient material recovery process. And thirdly, remember that sustainability is not a solo endeavor. So you need to collaborate across the entire value chain, which actively engaging your suppliers or your customers or your partners to co-create and regenerative and resilient ecosystems. And the fourth is the important one, like is the upskilling for sustainability. I would suggest to empower your teams at all levels with essential knowledge and the right tools they need to design, engineer, and operate in a sustainable manner. And finally, be bold and be early. The organizations that are taking a decisive step in a sustainable transformation now are not just becoming leaders, but they are actively defining the standards for the manufacturing industry of tomorrow. So, as we come to the end of today's session, I want to sincerely thank our expert speakers, Sujita and Jason, for sharing their valuable perspective, and each and every one of you in the audience for tuning in and engaging with till this 1 hour. So, to sum up our key message today, we have explored how sustainable manufacturing when smartly driven by data insights and circular innovation. So it's not just a responsibility we must bear, but it's also significant and exciting growth opportunities for the future. So it's been a pleasure having you all with us. Thank you for your time, and we hope you have a wonderful rest of the day.